Welcome to Behind Closed Books, the podcast where business owners and experts reveal the financial decisions that shape their success. Each episode brings you unscripted stories of turning points, hard calls, and the numbers that changed everything to pivot, recover, and grow. If you're building a business and ready to think differently about profit, pressure, and progress, behind every smart decision is a story worth telling. This is the show. Here is your host, Craig Sheets.
Hello, everybody. Welcome to another episode of Behind Closed Books. My guest today started off in his industry at a very young age of 19, and he's been working in the same field for over 45 years now. He helped invent cutting-edge technology that can save both money and lives, utilizing, of all things, concrete. With that, everybody meet my guest, Paul Falco. Welcome to Behind Closed Books, Paul.
Hi, Craig. Thanks for having me. Appreciate being here.
I'm really excited today. Today, we're going to be speaking about the construction industry, the ways in which a brand new technology patented by Paul, by you, that can help save lives and protect property. Nobody would ever think those two would go together. And another technique you invested in saves millions of dollars in the construction industry. And then some of the latest trends in the construction industry as well. So I guess we can start with this. What is cellular concrete as a material?
The cellular concrete is a mixture of cement, water, sometimes sand, and air bubbles. And we're creating a micro bubble that is smaller than a grain of sand. So it doesn't crush in the mixture. So we're able to pour stuff that has maybe 75% air, and we can pour it in, say, road-based material and then drive over it the next day. It's used for filling up all different types of voids. We've used it on dams for backfilling where we are repairing dams. We've used it on levees. We use it underwater on the Pier 88 and 90 up in Manhattan in New York City for encapsulating those piers. Those piers were built back in the 1700s. So those pilings are still wood from that long ago.
Wow.
And they're becoming deteriorated with slipworms, all type of things. So what they do, we box up a section of pilings, say 10 or 15 pilings in a square block, and then we put our material underwater. So we make the material at a specific weight. So it's not going to be too heavy to weigh down the soil or the silt that's underneath the water, right? So we don't want it to be floating. It has to be heavier than water, but light enough to not cause a downward thrust of pulling the pier down into the mud. So we create a design that matches what the engineering firm is looking for, and we're able to produce that on site with the equipment that I've invented. We've gone from that type of thing where we can build homes with this. Again, it's a density that can go anywhere from 25 pounds a foot, which is very light and floats in water, to 110 pounds a foot and would have a tremendous amount of strength. So having something lighter but yet stronger for the construction industry makes a big deal. Just if you're building a bridge and you have the material that's very heavy, then you need more structural support to support that load. If you can lighten the load while maintaining the strength or even increasing the strength, we have a much better product that would stand up a lot longer in time. And this is,
but those who don't know the construction industry, I know there's a difference, but is there a secret sauce or a certain ingredient you can even talk about that's different between what you're referring to, I think, which is the cellular concrete level and just regular concrete?
There's quite a bit of difference between cellular concrete and regular concrete. Now, we do a structural cellular concrete, which in all appearances looks like regular concrete, other than it has a different density, it has a different makeup in what we're putting in there for the ingredients, but we're still using cement, water, and sand.
Okay.
In most cases, we're not using gravel or rock that they use for the aggregate in regular concrete. So what happens is that with the air bubbles are replacing the aggregate. And now we're coating those air bubbles with the cement paste. And then those little air bubbles, they have a small amount of moisture in them. So what happens is that as the concrete cures, because it doesn't dry out, it cures. The water becomes part of the mixture, part of the concrete.
Okay.
And concrete has a habit of cracking and shrinking because it's drying out from the outside faster than it dries from the inside as it's curing. So by adding the air bubbles with water moisture inside the bubbles, we're hydrating it from the inside out. So we don't have any cracking. We don't have any shrinkage. And so now we're able to use a material that has a lot less flaws in a finished product. I have an invention from 22 that I got a patent for that we can install this into the ready mix industry. We haven't raised the money yet to go into that industry yet, but we've already proven it. I've used this apparatus and this invention on a job with the ready mix company. We were on site with the company for 13 months. The batch plant broke down 3 times. My stuff didn't break.
Still always happens with construction, isn't it? Never goes to plan.
We know how well it works, and then all the different designs. That's what we spent a lot of time. We do a lot of time in research and development, which doesn't really pay us any money. It's a big expense, but it's necessary for us to understand how to make things different and better. We have to study, and that study takes an awful lot of time and effort. Our latest thing that we're doing is with a fireproof panel.
This is exciting.
The fires in January, it was just horrendous to see what was going on. And I have something that would prevent that. And we did one back in 2013 that we had encapsulated a home. It was for a free project for Habitat for Humanity. And we donated our time and materials, and we encapsulated an existing home. Instead of them tearing the home down and building a new one, we built them one using the existing home as the form. We formed on the outside of that, created a skin over the outside, and that house still looks just as good as it did today as it was 15 years ago when it was completed.
What you're saying is you can take an existing home with this particular product you're referring to that can save lives by being fireproof, and you can put it over the outside of the existing home without having to tear it down.
Absolutely. And that's the whole thing. And look, we can build fireproof homes now, but you can't fix what we have in place. That's where the real problem is that, and when you look at they talk about a housing shortage. We're short by 1 million houses a year or some, I forget the number, but we're losing almost 1 million houses a year to fires. I think in this last year, they lost, I don't know, whatever, 20,000 homes up there in Los Angeles.
Los Angeles is horrible. We're a traffic.
And that's not new. I lived in Southern California for 35 years, up until 2014. I was there from 1977 to 14. And in that time, we had fires that burned down the homes at the tops in Laguna Beach. A fire started way out at the freeway. There was some type of delay on which fire department was going to go and put that little fire out. And the wind kicked up and kicked it down the canyon. And that was, you can't stop it then. And that's what happens in California. If the wind picks up, we have very steep hills, very dry brush everywhere. Most of the time, they're in a drought out there.
So that's this kindling wood for the kindling for the fire.
And a lot of this stuff is it's not just kindling. The stuff that's alive, the chaparral, these low bushes, they have a oil in them. And they just burn hot and fast. Once it starts, you really can't stop. So what happens is it reaches up to the houses at the top of the hill, which are the most expensive houses. And the heat alone is just too much to bear. If you just put it on stucco, which is what they have on the outside, they have wood studs. They have a plywood exterior with the stucco over it. Within 20 minutes, the stucco is heated beyond the wood tolerance. It's going to catch on fire. 580 degrees.
Yeah, no chance. And fires burn at how many thousand degrees is it?
A forest fire burns somewhere around 1,200 to 1,500 degrees. A very hot fire that's being stoked by flames, you'd be up to maybe 2,000, maybe 2,100 degrees. But those temperatures don't last for hours at a time. They only last for as long as the fuel is available.
Okay, so it's hot, heavy, quick. maybe for a couple hours, but it's not going to stay at 2100 degrees.
It's not, it can't possibly, there's not enough fuel. It has to have enough fuel to keep it going. Just like if you're stoking a fire in an old steam engine, right? The engine, you're shoveling in the coal and you got to keep it going. If you don't have any more coal, the engine stops.
Yeah, they're always stoking the fire. You see all those pictures of people all in soot and everything. Stoking those fires for a long time. Not a fun job, I imagine.
No. And then we look at, encapsulating the homes, we could do it like that. So I thought maybe we should do a panel, something that we can install piece by piece onto a home without having to encapsulate the whole entire house at one time, which would be a way that other people can do this, not just our company coming out and using a special technique. We want to have it so that this can be done by all builders. And the idea behind, besides just not burning down, it also is going to increase the insulation value of the home. And we can create a home that reduces the energy consumption for almost up to 75% less energy consumption.
The heat from the outside as well. So if it's a hot day in Los Angeles, would this material help insulate any heat coming from inside the house?
Absolutely. Well, we put 2,000 degrees on an 1.5 inch panel, ran it for 4 hours. And it was 2,000 on the outside. On the back side, it only increased up to 250 degrees. It's got to get to 580 to catch the wood on fire. And that was 4 hours straight with 2,000 degrees on it. We're not going to have that in any situation. So what happened was one house catches on fire. It was a pretty common occurrence in California, having high winds, and somebody with a matchbook decides he's going to go and light a fire, because that happens an awful lot. In this case, apparently it was some type of down power lines a few days earlier than when the incident happened. The winds came in and out. We heard it. I'm in Florida, and I heard the news a week before that happened that they're going to have unbelievably high winds in California. I heard that everybody knew a week ahead of time that they were going to have these high winds. And then, and you saw the fires with these embers blowing sideways. It's an amazing amount of ash burning. So what happens is it gets up under the eaves of the home. It goes into the vents, lands in the attic. The wind is still blowing. So now it's stoking these little embers in the attic. Next thing you know, the house is on fire. It's like burning from the inside out.
Right. It's like stoking the fire, like you mentioned, literally like stoking the fire with one of those old stokers. And blowing
that's right, because the wind is blowing. It was blowing, I don't know, 60, 70 miles an hour. It's an insane amount. You can't stop that type of a fire unless, of course, you have a non-combustible material on the exterior. So what we came up with, I got a plan. You can see maybe on the wall behind me. We have a plan, a design on how to make this happen, right? So what you do is we put the new material over the existing stucco. And then we box in the eaves, and we use a fine steel mesh for the venting so that the embers can't get in. So even if the embers, it gets caught in the eave that we boxed in. And now the wind is no longer blowing into the attic. We're still getting ventilation, but you're not getting high winds. We have a wind buffer. Now it blows up underneath the eave, but it has to go through the fine vent. So now that wind is cut way down. Now the embers, should they go into the eave area, which we have encapsulated with non-combustible material, nothing can happen. It can't get up into the attic. It can't cause the fire. And the other savings is now when we have this on the stucco on the outside, then the heat from the house, say a house does catch on fire next door because there's a kitchen fire. The house burns down. The heat from that house is also catching the other houses on fire because it's just too hot. And it's sustained for a pretty long time with a house burning. You got
the homes are close to each other out there too. A lot of times they're within hundreds of feet of each other. So heat from one or the fire from one. When
most houses in Southern California, you could run and jump from roof to roof with. That's how close they are. The eaves, I believe, are 5 feet apart. That's the eave itself. The houses are supposed to be 5 foot from the property line, but they got a 2-inch overhang.
Oh my God.
You're within 5 to 7 feet to another roof.
That just adds fuel to the fire. I'm saying that literally adds figuratively. Yeah.
And almost every house has some type of a fence around it, and many times those fences are wood. So
adding more fuel to
So
the fire.
the barrier between one house burning and the other is a very highly combustible material, which is wood that's been out in the sun drying for years as a nice little kindling to help burn your house down.
So all these factors coming in together are going to cause obviously more fire opportunities. But when you have this kind of material, and you're not just doing the material, you'd mentioned there's a wind buffer as well. So you're looking at the whole house as an entity, and from an engineering standpoint, saying what are the different ways fires can catch, and you're checking it through the wind, you're checking it through the eaves, you're checking it through the actual concrete. So there's a lot of factors that go into this. It sounds like from a technology standpoint.
Yeah. Well, and we've spoken with the fire departments, the fire chief. What's going on? Where is this fire really starting from? And these are the answers that we got. And you could see the wind blowing with those embers going that, and one house, it looks fine, but is burning from the inside. That's how it's happening. So not every house has to be completely encapsulated. There'll be, most houses can be protected with just boxing in the eaves, changing the ventilation system into the house that no embers could ever get into the house, but we still want to be able to have some kind of ventilation.
It's got to have that vent through, let the heat escape as well, both ways.
Exactly. So this is a way that we can protect it for not having to have someone have to do the complete home. Now, there's some homes that are in very precarious places, and they're usually very expensive homes because to get that nice spot up there, it costs a lot of money.
Well, of course, you want to be high view. You want to be up at the better view, so you're up there. It costs more.
And at the top of the hill, where's the fire burning? It's going up.
Of course it is. And it's getting hotter as it goes. I know in accounting, they use a method called percentage of completion method, which is as you're constructing a home, you take a certain percent and then you start expensing it as you go. But it sounds like you're in the end phases in some cases where the home's already built on the houses that are pre-existing, and you just add in like what, icing to a cake? You know, it's a bad analogy, but it's added to the
that's about right. We're going to add an exterior skin, whether we set up and form around and pour it in one monolithic pour, or we use panels, as I'm suggesting, that we attach these panels just like we do in EFS stucco material. It's like 1.5 inches of foam that we attach to the outside of the building, and then we do a stucco over the top to get more insulation. We were doing this probably back when I was building custom homes in 2003, 4, 5, 6. That's when we were using this type of material.
Yeah, I was wondering how you do that to existing homes. You can't just take it and put it like a cake batter on the outside or the icing batter.
Now,
you got to fix.
If we form it up and pour it, you can, but that takes a lot more work because now we have to put a new wire to be able to hold it on. We have to have a lot of flashing around the windows and everything that we have to put in before we pour it. We have to extend all of the plumbing. We have a home spigot that's got to be extended out because now the house is another 1.5 inches thick. So we would pour either 1.5 inches to up to 3 inches, depending on where the house is, what it needs to have to be completely protected. Building new homes, the same thing can be used. Instead of just stuccoing over that plywood right now, we put this panel on, then you stucco over this panel. So this can be used for new construction right now. It can be used for, and in the most part, it's existing homes. That's who's in the way. The existing homes are the ones that are in the most danger right now.
Of course, yeah. They've been around long enough. They're old wood. They're easy, like you said. Some are dried up from years, and the ventilation isn't proper. And there's a lot of exposure that way.
Yeah. To me, that just coming up with a method for new construction, we already have that. You build a concrete house, you build a steel stud house with concrete board on the outside and a different type of drywall on the inside. We're working with another company that's doing that. They're making a drywall using about 75% of our air in the drywall and using a gypsum material that they have a gypsum mine, one of the biggest ones in the country. And they're mixing the gypsum with this to create the drywall that can't possibly burn and gives another insulation value.
Okay. And the gypsum's not part of the fireproof part. That's just what's mixed in with the technology you've invented.
Yes. So it's being used in a lot of different ways. But after what happened this year, we went right to work on research and development. We spent a good 6-8 months creating a panel, doing different testing. And when you're doing your research and development, you can't just change a whole bunch of things. You got to change one thing at a time, right? So you have the same test, and we're going to change one thing. And when you test again, we're change one other thing. You cannot change anything because you won't know what's going on.
You got to have a test in case of each one test, and then otherwise you don't have
one thing built on another. So I'm using different elements within that panel besides just the cellular concrete. There's other things that help not burn. The type of sand we use. Instead of regular sand, we use a silica sand, which is much more heat resistant.
Okay, interesting.
So we were also attempting to use different types of clays and so on that are very hard that they use like in furnaces, right? For fire brick clay, that type of stuff. So we try different additives such as that in the mixture. Will this give us more resistant to the heat and so on?
Are you trying to utilize local resources? So if you're building in the U.S., you want to try to use different sands and different materials that are available more in the U.S. than other countries?
Absolutely. Everything that I'm trying to use has got to be easily accessible. Otherwise, it's a hybrid that no one can have.
Because you're sourcing things over in the UK or China or Canada or Mexico, it's possible you're going to add to the cost by having to source it from other places. You want to absolutely local resources and different quarries, or as you mentioned, sands. What about the construction process itself? When you do this, are you bringing your actual technology trucks to the site, or are you doing the concrete and then shipping it to their concrete mix? Are you
in most cases today, we bring our equipment out to the job and we're producing on site because we're usually producing large amounts. We do a lot of work for power plants and utilities like that, dams, levees. And in all cases, we have a non-disclosure saying, I can't even say which company I'm working for. I can't even say I have a non-disclosure with them.
Right.
So,
super secret.
They do this work, but nobody wants anybody knowing what's going on or when there's work being done on any of these facilities, like a power plant. You got to go through a lot to get in there. Okay.
Right, I got you.
You can't send anybody out to the job. So we have to have quality people working for the company as well. Everybody's drug tested and all that kind of stuff. You can't have criminal records and
no, everybody's going to be in the up and up and vetted. And we had a recording before this with someone from a payroll company. We were talking about how important it is now, making sure you're hiring people from the country, and actually business owners now can get in trouble if they are hiring people who aren't documented and employees.
Well,
that's absolutely payroll company now. So that's a side note there, but that's
my years in Southern California. On a Saturday, I might pull into a gas station in my pickup truck, and I got to start throwing guys out of the back of the truck. They're just jumping in. Oh, we're not working today, guys. I'm not glad you're getting funny.
They see it just part of, hey, he's coming to pick us up. No, this isn't the pickup. I'm just getting gas for real.
70s and 80s. And then things change after that, too. That less and less of that happens. But I had a lot of Mexican guys that were legal guys that worked for my company. And several of them set their next generation, the first one to ever go to college. And they're following for me. And again, there's good people from all over the world and all over the country. And I don't know, I come from a time I worked for a living. I enjoyed it. If I could still work, I'm 66 now. I can't be out there. Though I'll tell you, I can still sink a 16 penny nail on one strike. One start, I'm done one hit. I can put the nail in. And most guys still can't do that. You really hit the nail.
I'll say I probably lose a finger if I tried to do that once, but let alone hit the nail. And so, yeah, since 19, you've been working. That's a long time.
That's right. I'm still in shape. So, there's a benefit. Doing that. I have plenty of guys that work for me, but I couldn't stay off the job. Even today, I'm out in the shop and the guy's going, put that down. I'll pick it up. I'm like, I can't just stay there all the time.
No, I know. You want to be involved when you see.
I got to get my hands dirty. It's part of the process.
It's your DNA. It's in your DNA.
Yeah, I can't stop. I'm writing my book. I got a book here I'm writing. I already wrote a book about cellular concrete. I'm writing a book about other things now. I do music, write songs. I record music. I don't watch TV.
You seem to be a person that always has something going on. And with this kind of technology you're talking about, you, like you said, you can't just say, okay, we're going to change the whole formula and then test it. You got to keep the formula as is and then test a new one. So it keeps you busy. But as far as the latest trends in construction, it sounds like this has got to be one of the biggest ones out there. Is there other new trends in the industry of construction, maybe even from a different standpoint or in the concrete world? And these two things you talked about right now, cellular concrete and the patented fireproof, that's enough. But is there any other trends you've seen in construction, whether the way they're doing things or building out?
So a lot of they're trying to automate a lot of this stuff. They're trying to do a factory. They're trying to build smaller and smaller buildings. We went through a period of what they called the McMansions, right? We were building,
Oh, yeah, we did.
very, very nice homes that were pretty big, a lot bigger than they needed to be, a lot of extra space in the home that's not necessary. And it's coming back around to smaller, more efficient buildings that they're building. So
Right.
I don't care for the style. I like old world style.
Right.
I'm not for the square, flat building. When I first started this with cellular concrete, probably almost 15 or 17 years ago, my mother says to me, "That house is going to be ugly made out of concrete." I go, "What do you think it's going to be made out of slabs?" You can make it any shape you want. It's just a material.
I was saying, liquid materials, you could bend and shape it, I guess, in different ways. Whether you
a lot more elaborate with that. You can put it in round curved walls. It's a lot easier than you do with wood. You can make them out of concrete like that.
Yeah, actually, matter of fact, I think we're talking to somebody in one of our podcasts next. It does, and I got to get the words right. I don't want to say concrete shaping, but concrete etching. And you probably know the word better than me. But once the concrete's there, they design it differently. I don't know what the word would be. But he's coming on the podcast in a few weeks as well. And that's
they're doing all kinds of things to use concrete as the finished product now.
Yeah. So you would
And
come
they-
in
you know,
concrete, and he come in after the fact to design it and make it look. It's kind of like architects and engineers. I always hear that they're kind of like cats and dogs. Architects want to make it look pretty. Engineers want to make it stable. You would.
That's exactly right.
You
know,
take
in-
the long
In
run.
that case, what usually would happen be, if we can't hide it, let's feature it, right? So we got to put a big beam in. Let's make it look real pretty. We're going to decorate it with moldings and so on it to make it look nice, so that we put it there on purpose, not because we had to put it there because we want to make a bigger span. Other
Right.
times we would hide it up in the attic. We would put the beam up high and then hang everything from the beam in order to hide that beam, which is another method. And so you got to be a little bit creative if you want to have things the way you want it to look, and yet it still has to be structurally sound. So
Right.
I like to go above and beyond with the structure, and then above and beyond with the aesthetics. I
And
want
that's what
people
people,
to look like I want to live there.
yeah, engineering, architects, again, the same thing, trying to get the two to come together. That takes some really special talent to be able to do that, make it look pretty and have it structurally sound. That's really the gold standard.
Exactly. So now let's make it pretty structurally sound and it doesn't burn. How about that? Let's just stop making houses out of kindling. We've all
Fine.
heard the story of the three pigs.
Yeah.
Right? Why are we building houses out of straw and wood? We should be building them out of brick.
And we
Okay.
have the same thing here in Florida with people building houses that are just one plywood, and you're in the Hurricane Alley here. As you mentioned, you live in Florida, as do I. And it's a different issue here. We may have some fires, but not like LA. We have more wind issues where a lot of homes aren't built, or they're not double strapped on the roof, and they're not, things are precautioned correctly. And then they're like, well, what happened to this house? It's like, the technology has been available. There's hurricanes coming. You got to build it under the structure so that it can withstand the winds. And you just got to think of the future. You can't just save money and cut costs.
Okay. Exactly. And again, we have existing buildings that people live in. So if we're building 1 million houses a year to try and get up with the 5 million deficit, but yet we're burning $650,000 or 650,000 houses down a year, it's a little hard to get ahead of this problem. We don't have really a housing shortage problem. We got a housing fire problem. Okay.
Right.
That's what
Right.
we got. That's
Right.
what the problem is. And not all the houses are. Most houses, I think 250,000 a year burned down from a kitchen fire.
Oh,
And there are several simple apparatuses that are on the market today that can be installed in the kitchen above the stove area. They said, we have a fire extinguisher ready. If you were standing there and the fire started, you probably wouldn't have a fire in the first place. The reason they got a fire because you left.
You
You
would
went out of the room, you forgot, you're cooking something, now you got a fire. Now you can't get the fire extinguisher. Guess what? Because it's next to the fire.
exactly. Then you can't get your hand in there because you went to go change the channel, or you went to go use the restroom or something. You forgot. You have to
Exactly. That's really how it happens. Not that you're standing there, oh, the fire, and then it catches the kitchen on fire. That doesn't happen. That's not how it happens.
No, it's
And the
flat
same
fires
thing happens
everywhere.
with, like the furnace room. In California, we have like gas heaters for that are in a closet in the hallway in the house.
Yeah.
And you put 2 layers of drywall and you're fireproof.
No.
Maybe we should line those cabinets with this other material. Again, it can't burn 4 hours at 2,000 degrees, and it still doesn't allow the heat. And that's only an 1.5 inch piece.
Yes. That technology is amazing. And I guess I'd be remiss not to ask, as far as cost-wise, and of course, being from the accounting and tax background, cost-wise per unit, I don't know how you measure units of concrete, if it's pounds or gallons or what the...
We're usually measuring cubic yards of material.
What's the cost?
Cubic feet of material. The material itself is not very expensive. It's the process. You got to go through and do all this work on the house. So myself as a builder and a remodeler, I look at this as a piece of cake. We make the house look better than it used to look. So you got people with very expensive homes. They don't want to look any worse than they already look. No, you want them to look very nice. So we make it look exactly how it looks now or better. We could give you a facelift. We could do something where we change the look of the house. If you want it to look like it had the old colonial style and where it has a buckboard siding, well, we make that out of cement board. And there's plenty of companies that sell cement board. It looks like wood. So under that cement board, we put the fireproof material so that the heat can't transfer. And then you finish it with the cement board and paint it look like any of the homes already look. Again, there's whether you got to do stucco, you want it to look like brick. We've done stuff where we can have the panels pre-finished, but again, that just increases the cost to the consumer. The way I look at it is we can do this and do this work, but I can only fix so many houses with my company. We need to make this available to all builders, to everybody, in order to do this. And
Now, is the cost per cubic yard, I think is how you measure it, does that cost, let's say you're building a new home and someone's going to say, you can build this home fireproof with the technology, or you can utilize the old methodology per cubic yard. Is there a massive differential in price for new homes if they were to use this material?
no, it would be the same either way, because on a new home, you wouldn't have any other work to do other than we put this panel on, then you do your stucco or siding or finish, whatever your finish is going to be. Instead of putting it right over the plywood, which makes the house valuable, we pick this panel in between to stop that. So instead of saying, well, you got to redesign how you build all your houses, you can't use wood anymore. That's not going to happen. That's not going to happen. That's not building out of wood ever. You can build some out of concrete, but then, like in California, part of the problem with the concrete is the weight of the concrete. Conventional concrete with earthquakes, you have it. Again, the heavier the material, the more apt it's going to be to fall to the ground during an earthquake and the ground shake.
Never thought of that. That's why you're obviously in the industry. I would have thought of more from the fire or wind, but you're right. Earthquakes makes things heavier.
And so everything's got to be built to the code for earthquakes in California. There's no way around that. So wood things, they can move. They cannot fall apart. It can still move a little bit, roll with the ground, but the concrete is solid. So you've got to have even more structural capability with that material. And so it doesn't make it less expensive. And to me, we're already building with wood. They can go to steel studs if they want, but if they're already building with wood, why try and make them stop building with wood? Let's just give them a product that they can put over the top. This is where we are. We're in our research and development. We've proven that it works. We have the experience to do it. Now we're just looking for the investment money to go ahead and open up a plant that we can make panels, that we can make these panels. We can start installing them on houses. That's the next step where we are.
That's great. Have you spoken about this product anywhere around the world? Have you done any speeches or presentations about this?
I'm not particular about this. I did do a university tour back in, I'm going to say 12 or 13, and I demonstrated the capability of this material. I would go and I bring in 2 pieces of material that I would bring. It'd be about an inch, 3/4 of an inch thick. One would be conventional concrete, and it was just a little round 4-inch disc. And I would take a blowtorch and I put it while it's on my hand, and I would heat it up. I would heat up the regular concrete, and then I put it in a stand, and that thing stayed hot for the entire meeting. I would heat up the other one for twice as long with the cellular concrete. And as soon as I pull away the heat, I put it in the stand. Within 4 minutes, the thing was cool. That means it doesn't absorb the heat. So we did the meeting. I did my talk. At the end, I passed them all around. The regular concrete was still very warm.
Wow. So you'd actually show a visual example of how this worked, not just in a talk, but you're showing them the product itself and how
you can get it at the university level. And we work with them. Right now, we're working with Columbia University on testing with this material. We work with FSU University. Actually, they have a proposal to us to do a study of trying to add nano bubbles to the mixture to try and make our bubbles even smaller than what they are.
Into the nano world, which everybody's talking about with technology and science. That whole world is a different, literally, universe. That's getting really
things change at the nano level. So
I wouldn't even know where to go, because then, at that level, things could be changing. So your product could be different again. You'd have to restructure some formulas possibly after that.
And so those are the things that we're working on to try and bring this to everyday market. One day you'll be able to buy these things in the Home Depot. I'm pretty sure. And so the idea that we just are looking for a couple of brave souls that want to invest a little bit of money, but I think it's a pretty darn good investment. I've poured my own money into this thing for the last year. I've been funding this thing personally, and now we're ready to take it to the next level, and that's more money than I have. And so now that's where we are. That we're talking with different partners about getting involved and taking this up to where we need to go with it, because it's something that needs to be done in this country to help us with enough homes for people, and then we're not losing them. Since we began this call, another house burned down in this country. They burn down at 32 houses a day. That's the average rate of homes burning down. So that's 32 hours. That's more than a house per hour.
It's more than a house per hour.
45 minutes, another house burns down.
Wow.
And that's not changing unless we do something else.
From a financial standpoint, it's going to be a bit of a burden to you. Are you going to so you might work with a conglomerate of other people to help with the funding, because obviously financially on your own, that's going to be a big burden to take on. So you could bring.
Yes. And what's going to end up happening is that we'll end up being acquired by someone else that will take over most of the company. They don't let little guys like me go all the way to the top. I get to invent it and come up with the idea, but someone else will be the bigger winner from this. For me, this is just what I'm doing. I'm here to make a change and make something that is worthwhile, last longer than my lifetime. When we were building custom homes in Connecticut, a lot of people would say, well, gee, you're not going to make enough money building the house like that. It's too elaborate for what the market is. And I'm saying, I don't care. I want a house that 100 years from now, people are still going, that's a nice house, right? It's not, that little box over there. No,
I want something that withstands the test of time. And there are homes out there that are 100 years old, and they're beautiful, sometimes more intricate than today's homes. And they're still
most from the past is a lot nicer than what we're doing today. And
100%.
I understand the idea that they want to produce everything in a factory and ship it out to where it goes, but that's not going to work, because the farther away as you build around the factory, now the house has got to be shipped further and further away from where you're building them. And we're not making shoes, okay? We're building houses, and houses traditionally have been built on the spot where they're going to stand. And the method should still be the same. We would just bring out a mobile factory to the neighborhood, and we set up a mobile factory.
Your building is your product's going to come to them and a form in which you do in a major neighborhood. You could do it all at once with a mobile factory, would be more efficient. From a money standpoint, again, coming from the accounting side of things, if you can set this up and utilize your concrete from multiple homes, whether it's to update an entire neighborhood or if it's to build a neighborhood, it's going to be a lot cheaper and more efficient for you to bring that out for 20, 30, 50 homes rather than just one home at a time.
Exactly. And so that's what we propose for rebuilding those homes that burned down in Los Angeles. You'll never build them back at the regular rate. That's not going to happen. We have to actually get out there with several builders, and we do a steel stud factory right there with the concrete panel factory.
Wow.
We have the walls just pre-made in the factory, bring them up to the site. You can put up a house with steel studs in 3 days as opposed to a month of framing. And again, everything can be increased in how fast we can do it, and that the efficiency goes way up.
Of course. Yeah. The more you can do at the same time, the efficiency goes up, but also the price comes down as well.
Absolutely.
Price per cubic yard or whatever you want to measure it as. So you can do 50 homes cheaper per unit than you could just to come out and do one home and leave. So getting the neighborhood HOAs or getting new builders or talking to construction companies to get into them, whether you go to their meetings or go to their trade shows or just the people, that's the way to go about it. And you're saving lives when you think about it. There's also there benefits for termites and mold and things like that.
Of course, you can't have any mold. You can't have any termites. Our material doesn't absorb water like regular concrete absorbs 56% by weight of water. Wow. Cellular concrete absorbs 15%, and we even have it down to 7%. So it doesn't absorb water. I can take a piece of cellular concrete and throw it in a fish tank, and it'll float for a year. It will never absorb water. It's not a sponge. Regular concrete, you can't. Even if you make it with a pumice material, it's going to absorb the moisture and it's going to sink. It's going to lose its buoyancy. So for the last, 7 or 8 years, I would have a college student that would call up and they're doing the concrete canoe contest. And I had a couple students that they won the contest, and I gave them a formula. Here, this is what you do. Here's how you make it. Here's a free gallon of my chemical. Here's how you mix it up. Here's the formula for the mix. And yeah, you can make it lightweight and very, very structural still.
It's funny. Yeah, you kind of gave them the secret sauce. It's funny. You mentioned universities earlier, and I'm thinking from a tax standpoint, going along those lines and working with engineers and architects that utilizing the research and develop credit from the tax point of view with the new OBBBA, a lot of B's in that, but the new tax law that came out, they're extending the research and development credit. I know that's a big thing for people in the industry right now, is to say, how can we utilize that research and development credit? There's a lot of criteria though that goes into that, and some things like whether it's salary or the cost of going to a university or the cost of hiring a scientist to do different studies. There's a lot of different aspects to the research and development credit that can be utilized, but what you have to do is you got to meet those criteria. So it's always good to talk to a tax person and say, hey, I might be in an industry that utilizes research and development credit, and there's specialists that can help with that. So it's nice. You touched on that earlier, and I know it's a very narrow world, but it's something that could be utilized that I want to bring to people's attention during
the stuff do is what keeps guys like me in business. Okay. This is how we keep going. Okay. That we have to utilize all of the laws that think that are available to us. And on my end, I don't know what that is. I can only focus on what I do. Like you focus on what you do. I have to focus on what I do in order to get the most out of it. And if I'm not worrying about how much money, then I got a problem. It's hard for me to just say, no, I got to do this. I have to do this test. We don't have enough money. we'll find the money, because if we don't do this, we don't go to the next step. And so this is how we make it. And you know what? When he comes,
with the opposite of architects and engineers who are cats and dogs, you'd think more with construction and people utilizing research and credit. With tax accountants, they're more symbiotic because you got to work together, as you mentioned, because you do an industry that's something I wouldn't know how to work in, but then I work in an industry you wouldn't. And that's where businesses and tax and bookkeeping come together to say, look, you do what you do. I don't want to get into cellular concrete. I don't want to get into fireproof concrete, but I can help you behind the scenes to make sure that everything's running smooth. And I take advantage of the latest laws and regulations and get you the best credits we can. So that's why working together with an accountant can be very useful, because it's not something you should know about, just like I shouldn't know about concrete. It's just one of those things that they're totally different from each other.
Everybody stay in their own lane. Well,
exactly.
I can't be everything. I do a lot of things, but I can't be everything. I'm very good with numbers. I can add up at the register before the lady tells me how much I owe her. I already know because I do it in my head. They taught us math backwards in school. They have you starting with the small numbers, moving to the big numbers. No, you start with the big numbers, you work your way over here. I can only be off by a couple of bucks the other way.
Exactly.
So to me, there's a methodology too on how you think about when you're doing your math. For me, it's formulas. I have to okay, how do I convert a gallon to cubic yard? Where's my so you have to have a formula for that. You have to know the formulas and be able to calculate them. And so,
you do. It's funny in accounting. I remember when I first started off back in, how do I even say when, but 30 odd years ago, we used to have, to the new interns, they'd have a formula, a sheet of paper that had about 50 lines of numbers. And what they do is they put like a towel over your hand, and they give you a 10 key is the old terminology for a calculator, 10 numbers. And we'd have to foot is to sum the total. And then you have a tape. The tape is the results after you put it. And we have to tear the tape off, tape it to the actual amount. Of course, the numbers were on there, but the total wasn't. You'd have to hand it in to your boss for the day and say, I footed the numbers, and they'd check it and say, yep, you got that one right. Yep, you got that right. You literally had to be able to stare straight ahead. In this case, they put a towel over your hand, and you wouldn't be able to see the calculator. And that's how they taught us, is that don't guess. Math isn't guessing. You need to know the numbers. So we were taught, and that's a problem I have, is the opposite of you. Is doing math in my head. Everyone's like, yeah, add up those 12 numbers in your head. I'm like, give me a calculator. I'll add those up literally in 3 seconds, faster than you can imagine. But in my head, we were taught not to, because we had to prove our numbers with tapes. So I think you said that. It brings me back to an old story from when I first started. But with you got to know numbers. I'm sure you have to know formulas. You got a lot of technology you dealt with. And
that's what I have the cheat sheet in the rig where the guy works from, where he's making these things on. Here's your step 1, 2, 3, 4. You do this number, divided by this number, times this number, divided by that number. Will tell you how, if you have 32 gallons of material, how many cubic feet is that? There's 7.48 gallons in a cubic foot. So you got to take 32, and then how many cubic feet per minute are you doing? We did 32 gallons in one, and it took me 12 seconds. So now you got to calculate the 12 seconds and 32 gallons. And so you multiply that times 60, divide by 7.48. Look, there's my number, right? So these are the kind of calculations that you're doing to convert. You got to convert liquids to solids, from a spread to a foot, and so on, to a cubic material, cubic inches, cubic feet, cubic yards. And then those formulas are all part of what we're doing when we're calculating this. So he's pumping, we're making 32 or 22 cubic feet of foam per minute with our machine. And the guy is going to pump his concrete. He's going to pump it at 20 yards per hour so that I can get a 45 PCF material. And then I know to move his pump from either 20 yards to 19 yards if I need to get a lighter material, or if I need a heavier material, I'm going to move them up. And again, this is a calculation I just did in my head. And my guy calls up, well, the target was 45. We were 45 with that calculation.
Wow, you nail it every time. Yeah, it's interesting because you're dealing with machines and you're dealing with human error, with people utilizing the product and making sure they're getting enough the line fast enough, or getting it out of the truck, dumping it if they need to dump it. It's a lot of different factors that go on.
There's a lot of moving parts.
In life.
Well, we have to order the cement to be delivered, right? And the cement can't sit there. If it sits there too long, we got to throw it away because it gets too hot. You can't see there's temperatures too. We got to check the temperature of the material we're going to put in the ground. And as we're putting this stuff in the ground, it also gets hotter as it cures. The heat of hydration. So we can only put so much in the ground at a time. And you have to be careful that you put too much in the ground in a confined area and you have all this heat building up in there. And then you drop some water down there. You're going to get an explosion because that water is just going to turn to steam instantly, which makes a whole bunch of pressure. You go from liquid to gas, you got a problem. So
I never would have thought of that. You're right. That's dangerous. It's something, of course, I couldn't think about. But if you break it down scientifically, what you just said, it makes perfect sense.
We're pouring this thing at a plant that we had to fill up pipes. The pipes were 10 foot in diameter and they were 1,000 feet long. So we're pumping hundreds of cubic yards per day. We come out the next morning, we got a vent about every 400 or 500 feet in that pipe. You can see the steam shooting out of that pipe from the day before work.
Wow.
And we're going to go pour some more on top of it today.
Wow, that's amazing. This is so great, everything you're talking about. And I thought we could do maybe is now transition and get a little to know you a little better about you, like maybe even from where you grew up from childhood, not so much where you are today, but maybe bring us back all the way to when Paul was young and where you grew up. Give me an idea where you came from, like originally where you
I was raised in Connecticut, a little small town called Wolcott, Connecticut.
Okay.
I did very well in school. I tested at college level in the 8th grade.
Wow.
I was supposed to go to University of Connecticut in the fall. I told my dad I can take the summer off. I had to go to Southern California. We had met a girl in high school that was from Huntington Beach.
Oh, that's serious.
I was to go to Huntington Beach. I got to see it. I got to go. So a friend of mine and myself, we were supposed to drive out there, but our car broke down and we ended up flying out to California, dropped off on the highway in Huntington Beach. I had $400 in my pocket in a duffel bag. Here you go. And I
something.
found a job. We met the girl was at a surf shop somewhere down the coast highway that we had known. Her mother ran a boarding house at the time where a lot of surfers came because Huntington Beach was like the surf capital. I tried to. I almost drowned one time. It was enough for me. And done. I'm not a big swimmer. From Connecticut, we're in the woods, not near we weren't anywhere near the ocean, and the ocean didn't have waves where I was from in Connecticut. No waves.
Close to New York City than the water. Or isn't Connecticut some parts close to a couple hours of the New York City?
Oh, yeah. It's right next to the city, but we had Long Island Sound. Long Island comes down in front of Connecticut, so there's no waves from the ocean.
No, of course. You're on the sound side. You're right, because you go the
sound
and the LA.
You have to go out to Rhode Island if you want to see waves. So I had no idea about surfing. And these guys thought they were smart. Oh, yeah, they gave me some big, huge 8-foot board. That I should have had a little small board, but they put me on a big board, and they sent me all the way out there. The third set, I'll tell you, those waves, 6 feet when you're on the ground, and 6 feet over your head, you're laying there. That's a high wave. And then it comes on the top, and you go rolling out another wave, and you come up, and here's the next one hitting you again. It's like, please, God, get me to shore. I'll never do this again.
Like a washing machine over and over again.
Absolutely. And you're rolling around. I go, oh, no, this is not me. I'm not doing this. But
not going to impress a girl to do that. Yeah.
So I went to California. I got a job for the summer working for a guy, and he was building patio covers, which were just little shade things over the back door, over the patio door that you would have a little shade area because it's hot in Southern California. That's what they had. So it wasn't a solid roof, but it was like slats that we put over there. And I worked for him for a couple of months. I called my father, said, I'm not coming back for college. And he was very upset.
Oh, I thought he was upset.
My younger sister's a lawyer. My older brother's a CFO for a company. Everybody's college. My father, my mother, everybody's college. And so I'm going into business, and they're going, but you'll do much better in business if you go to college first. I go, yeah, but I don't have time for that. I just don't have time for that. I'm a pretty smart guy. I think I'm going to do it on my own. So I did. And I started my company. I asked my father for money. And he said, we live in Connecticut. You got some money. No
Yeah.
problem. You come work for me. No problem. But you want to make it on your own? You got to make it on your own. Okay. And that was determination in me. And I wasn't going to go back. I was going to make it. So I saved up my money from working for this guy. He was going to move out to another, away from the coast, to Sunnymead or someplace like that. It was a new neighborhood. He had a young wife and kid. And so they were going to move. I bought his beat up pickup truck, set of tools that had like duct tape on the handles and was held together with tape and glue.
I see those kinds. I know what you're talking about.
Yeah. Right? And he introduced me to the guy that we were doing work for at the time, Japan Landscaping.
Okay.
And I got my younger brother to come on out. He did 1 year in college. I said, come on out here and help me. And we went to business and we started building patio covers for Japan Landscaping. And I had a whole list of stuff on my clipboard. And the guy would call me in the morning because, again, we had no cell phones. There was nothing yet.
Of course not. No, you're right. There's a dial-up. You got to use landlines.
So he would call me in the morning. I'd answer the phone. He says, you're not working. Yeah, he knows me. I'm home. I answered the phone.
I don't know where I'm going.
Job.
Give me
So we did very well with them. They were very good to us. They helped us along. I learned how to be in business. I learned about being responsible, about showing up on time where you're supposed to be.
Discipline.
As a young guy, you couldn't be out drinking and smoking dope and all kinds of stuff and be in business. So you had to get me on the straight and narrow. It's just part of the game. And I come to getting up early in the morning. Sunrise is a pretty spectacular thing to witness if you got a chance. It's not so bad. I seen plenty of sunsets, but the sunrises were the better. I worked on jobs. So my first job when I went to California, before I met this guy, I had to go for the job interview, and it was down on the Coast Highway. And at the time they were like mobile homes right on the beach. And people were like improving them. They were like making like permanent homes. And it didn't look like mobile homes, but it was right on the beach. And I went down to the job and I had to wait for the boss to get there. When did the boss get here? He'll come in after the next set. He was surfing. And I'm going,
no,
I want his job. I want where I got my guys working here and I'm out surfing on the water. I tried surfing far, but I want to be the boss, not the worker. So that's what I did. So I was the worker and the boss, though, because it doesn't really work like that off the bat.
No, you got to be your boss and job of this. And
my brother worked with me, and then I think by the time I was 19, or before I was old enough to actually drink, which I didn't drink anyhow, but before I was old enough to drink, I hired my first guy. I had people working for me. I think I was 19 or 20, and I hired my first guy. I applied for my contractor's license, and they told me I was too young at 22, that I could possibly have enough experience to get the 10 years of the journeyman.
Right.
So I took a few more years of having it than I had. Then the guy from Japan Landscaping, he signed the letter for me saying that I was qualified to be a contractor. I had another guy I had done work for that signed the letter. I'm qualified a contractor. So when I was 28, I took the test and passed the test, and it was grueling. It was 2 days of testing. 1 day was law. I passed the law first time, but it took me 2 times to pass the trade because you had to know about everything. Everything from, I was a carpenter, but you had to know every trade. Plumbing, electrics, everything. You had to be able to figure out these 4. They would give you a thing. Okay, I have a trench this deep by this long. How many cubic yards does it take to fill it? Those are the kind of questions you had to have. So right off the bat, you had to know how to do this kind of stuff if you're going to be in business. And so I got my contractor's license, probably one of the youngest general contractors in California. I'm still in my 20s. And I've been doing it ever since. Then I got involved with Cellular Concrete. We had been in Connecticut building custom homes. We go wherever the work is. And we were happy in California. But my wife's mother had passed away. And she was looking for a change. She needed family. My family all lived in Connecticut. So we thought we picked up and we moved to Connecticut. And then what are we going to do here? We bought some land and built a custom home. And wow, someone bought it right away.
something you're good
Then
at.
we got another lot, and we just put a sign up on the lot. I just put a 4-foot by 2-foot sign with a picture of the house I was going to build. I had people calling me up wanting to buy the house. I go, this is great. This is a lot easier than I thought it was going to be. We built a dozen homes in about 4 years. I built a medical building as well, 3-story medical building with the X-ray room. We had to put down the
or something.
had to put the lead shielding down in the flooring underneath the finished floor.
It produces a lot of electromagnetics, I think, and you got to be careful with it.
Yep, there's all kinds of stuff that we had to build into the building for that section and so on. We had a central elevator shaft and so on. It was a 3-story building. So that was my biggest building that I built. We came back to California in 2006 when the whole market crashed. We were building houses and it was going so good until I had one house. The last house I built that the buyer had to do all kinds of different custom stuff to it. And I forget what happened. Something happened where he wanted to get out of buying the house, and I was stupid enough to let him out of the contract. I'll sell it to somebody else. And that's when the market crashed. And we sold the house, but I lost $5,000 on the deal. So if I drove by that lot a year earlier and threw $5,000 on my window, it would have been way easier on me.
Yeah.
Those are the things that happen.
You got to have stories, pivot points in your career, things that teach you a lesson for better or for worse in some ways.
Right. And so we went back to California, and we sold our homes that were out there earlier, which is another mistake. We sold them, should have just rented them. But anyhow, so we were renting a place, and the guy next door was David Masters, a retired naval commander that had this stable air idea. They had a machine and the idea behind it. He had a patent for that original machine.
Okay.
And he kept talking to me. So I listened to him, and the machine was in Arizona. They had said they had built a house in Northern California that was insulated, but it's made out of concrete. And I'm like, I'm a builder. You're telling me I could build something out of concrete that had the insulation built in? I'm in.
Yeah, I'm in. Say no more. I'm with it.
So that was back in 2009. So it's taken me all the way to here. We still haven't built the house out of cellular concrete because we've been doing other things like with power plants, because we got to make money. And there's good money in doing that type of work. So the house thing got put on hold on. It doesn't matter what no one wants a house out of concrete, so I don't care. We're doing this. We're making a lot of money. And then the fires came. And I'm like, we got it. We got it. I can't ignore this. I know what to do to fix it.
That's amazing you thought like that. Where so many of the people before you probably just said, you know what, this is the problem. Someone else is going to deal with it, hand it off to somebody else. I'm going to do something different. You said, look, I got the know-how. I'm a smart guy. I'm going to see what I can do about it. And you start putting your mind to it, which is amazing. You did that.
And somebody's got to do it. And so here I am. I didn't plan on being the guy. I didn't plan on being this guy, but I am. So I might as well offer what I have to try and fix a problem that we have going on in the world. And the problem we have is housing burning down, not just shortage. We're short on houses because they keep burning down. That's why we're short on houses, okay?
Exactly. No, it's a good point. It's great that you did something about it. You've gone full circle now from when you started off in, construction, going back in California back when you were 19 to now, and you're trying to do something about the industry, making it better than it was before. And what a credit for you for doing that. You've done so much from, like you said, starting off, you wanted to look the earliest or youngest general contractors in California to today. It just shows what a credit you are to the industry. And that's amazing. You mentioned you wrote a book, I think, as well. Did I hear you mention that as well?
Yeah, I wrote The Complete Guide to Cellular Concrete, and then I can't publish it because I'm telling everybody my secrets. I'm not doing that.
No, yeah, I don't want to give away a secret, but I think you'd mentioned some kind of
book. I have another book that I'm working on. It's still a working title is The Hidden Universe. It's the space that connects us all. That's the book. And
interesting.
It's a little esoteric, but it's about my experiences on how I come up with these ideas that come to me. There's a method for allowing information to come. Every bit of information that we have that we can ascertain is all right here in all time. Anything that's ever been thought of or known, we're like walking through a sea of information. This is what
Right.
truth is. You slow your mind down. You're not thinking. No, you're receiving. Our brains are receivers and transmitters.
Right.
And if you quiet yourself down and don't think you know the answer and allow the answer to come, may not be the answer you were expecting.
Right.
You're going to get the answer if you can do that. So I spent a lot of time learning how to meditate, be quiet. I don't watch TV. The last time I watched network news was 2017 when Trump just got into office, and they were on the whole time to complain that he was going to do tariffs on China right before Christmas. Oh my God, everybody's not going to be able to buy Christmas presents.
Right.
And so they were on him for that. And then the announcement came, Lester Holt, Trump caves on China. I'm going, you son of a bitch. You were over here complaining that he would do. Now when he does what you said he should do, he's still a jerk. Oh,
yeah, you can't win with anybody.
That was since 2017. The network news has never been on in my house, not even with my wife watching. No, we don't watch it because it's not true.
Yeah, you want to make sure you believe what you hear. And you mentioned, I think as well, you were doing not a podcast, but you're doing some kind of a noir.
Yeah, part of my creativity. Yeah, I did a little short. They were like 3-minute long video that I picked pictures. And I would sit at home at night before I went to bed, and I get my recorder out, and I would make up the dialogue. And that's how I would. I just make up the dialogue. I'd stop. All right, here's another bit. All right, I do a little more of the dialogue, and then I'd have about a minute or 2 minutes worth, and then I'd go and get a bunch of pictures that kind of went along with that dialogue. And I thought, and then I put the music behind it with that noir, the sound of that, and it was fun to do. It's something that I got a lot of creativity. You got to keep letting it pour out.
You don't want to stifle creativity. And I think these were like a noir detective style. Was that the format?
Yeah, it was Collins and Shields Detective Agency is what it was. That was the name I came up with. And then I even made the people in my office like, all right, we're going to pose for some pictures here so we can put it on the thing here. Okay, all right, here, I got one of the fedoras and a couple of different hats and stuff.
I love it.
We did the picture to make it look like we were doing something.
I think that's great. Are those still available on YouTube or anywhere? Or are they gone?
No, they're not. But I was going to put them back up in a different place. When I started doing my thing for the videos I'm doing that are presenting the fireproof stuff, I didn't want to have that get mixed up with what I might be taking a little more serious with this, so I try not to. I don't want to be too frivolous with what I present out there.
I totally understand. That's great. Do you have anything you want to promote from your business standpoint? Maybe your business or one of your other businesses, or if not,
I need an investor. I need a money guy to come in and join up with us so we can open up a factory in California and start cladding houses. That's what I need.
Put it out to the universe. Do you want an venture capital, or do you want an individual or a business?
However it works. I'll take any way they want to. Again, it has to be done. We don't have time to wait around for much longer, because what happens is that all the interest is going to go away until the next house burns down. It could be 3 or 4 years from now, but we could, in that time between now and 3 years, when it all gets exciting again, that the houses are burning down, we would have them protected.
You'd already have done the work, right? So you're looking for somebody
fun. So we got to follow what we have with momentum right now. So I'm looking for someone that would come in, whether it's venture capitalist, an angel investor, or a larger company that would acquire us, that still own some of the company, but they would acquire us, and we would move with someone who has a lot more backing. And I mean, that's what it takes. In the end, it takes a lot of money to bring a new product to the market, especially in construction.
You touched on it earlier. You got to put things out in the universe because, as you said, there's receivers and transmitters. So if you put this out in the universe and tell them what you want, this is how things happen. How can they get a hold of you? What's your best phone number or email? You could share it here.
They could always email me at paul@cdibuild.com.
Okay.
Or my phone number, it's 949-573-0509. It's on our website. We have cellularconcretetechnologies.com. We have cgpsinc.com, which is our installation company. And I'm also Cornerstone Development. I'm a licensed general contractor in California. We're licensed, bonded, and insured to go to work in California. We have a small satellite office set up out there. I got a couple managers and about 10 subcontractors ready to go to work. All we need is someone to put up some money. We need about, I would say, to start off about $250,000. I need to get a factory, which is I just need a warehouse, not necessarily a factory. It's not like we're making widgets or any other kind of parts. A factory would be a place that we would just produce this material in forms and then cure the material for a month before we start installing. So we just have to have a place where we can make this stuff and then we can be sending it out and putting it on the homes. We have the contractors ready to go. I just need to set up a location in California. The problem, I have a location in Florida. We start doing it here, but the shipping from here to California, it doesn't work. We need to have a place there. Then I could train the people on how we would install it. We want to train the installers. We want to train the salespeople that are going to go out and see the neighborhoods, right? So if we train everybody together, when someone's on the job asking anybody, whether he's a guy with a shovel in his hand or a clipboard in his hand, they have the same answer. I want to be the best because I've had people say stupid and hideous things to customers on the job site because I'm the new guy. I don't know anything.
I know nothing.
Boy, that made that guy real confident in our company that we have a new guy standing on his job.
Oh my God. This is great. Paul, thank you so much. I'm sure our listeners love listening and hearing about your industry. What you've done is something that's unprecedented. And I think it's amazing what you're doing, not only for the cellular concrete level, but also fireproof level. And I'm so glad you're able to share your story and information. And I know our viewers are going to really love it. Thank you.
Thank you. I appreciate the time to come on and talk with you. And we appreciate all the work that you guys do for us as well. It makes a big difference.
I'm glad to do that. And that brings us to the end of another episode. And I'll see everybody on the next episode. Thank you.
Thanks, Greg.
Behind Closed Books podcast requires more than a conversation. It takes action, research, and collective wisdom. If today's episode resonated with you, we'd love to hear your insights. Join the conversation and help us shape the future together. We'll be back with more stories, strategies, and real-world solutions that are making a difference for everyone. In the meantime, be sure to subscribe, rate, write a review, and share it with someone you think would benefit from it too. Thanks for listening, and we'll see you on the next episode.